slowly start. Okay, got it. Hi everyone again. Good to see you all. Good to hear you all. See your reactions. This is the developer community call bi-weekly. Sorry, that's my YouTube started. Yeah, bi-weekly developer call. Fluence core team and the community, you guys. We can start if we have any updates. We can start with updates and then Q&A, any questions you have. And if anyone has the demo from the community, very welcome. You can show work in progress, share anything you've been working at. We can share some feedback and, you know, just let's keep it informal and let's have just nice time during this hour. And then we have Alexei today, Alex, who's gonna give us some updates on the node, right? What was the topic? Maybe you can.
Yeah, sure. I will explain. I was thinking to maybe show a bug fix that we did, but then I thought that I would better go through some AquaScript and explain how it works. I think that would be more beneficial and interesting.
Cool. Yeah. Do we have any updates from the core team today, Dmitry? Or no?
Hello. Actually, we don't. Because we are focused on stabilization, and it means that under the hood everything is better every day, but the only experience is that it just works as expected. So a lot of bug fixes, really a lot, and maybe Alexei will tell about some of them or like that. And we are doing some R&D which will take effect later, and it's mostly around introducing Fluence CLI, the new tool that will cover the development lifecycle of the Fluence project, and that will be like an umbrella tool for all the routines that developers usually face when trying to develop application. Working on the project with the code name spells, which is the effort to make scheduled scripts, the Aqua functions which are running by the Fluence network on the Fluence network, more robust, stateful, because currently they have no state, with access to some kind of key value store and many benefits. But hopefully I will cover it with a dedicated talk in a few weeks on one of the community calls. Currently it's under research.
Awesome, thank you so much. That was quite an update. On the community side, I can say that we are thinking if we are joining ETH Prague and Prague Blockchain Week, which is happening in the beginning of June, 5th to 12th of June, there will be a hackathon by local community and a week of events. So we are just considering that option. And then for the summer, in July, there is Barcelona, ETH Barcelona, the conference, and maybe they're organizing hackathon. They don't know yet, the organizers, so we will know about it in a few days next week. So we're joining that. We are planning to do a hacker house and a couple of events during the week, and we'll be inviting other projects to host their events there. That's the plan. And the same for Paris, ETHCC and Blockchain Week in Paris. That's more technical. And yeah, so that's the news. And for the August, we are going to organize probably DWeb Camp, co-organized with the Internet Archive. That's a super cool Burning Man for Web3, for all the peer-to-peer folks. So check it out for sure. We will post any details on that. But that's the camp in the Redwoods nearby San Francisco, and it's going to be awesome. All right. Does anyone has any questions? Maybe we go with the Q&A first. Anything or any work in progress anyone wants to share?
I had one question with regard to we had a conversation this afternoon, and I was having questions about how to integrate like nodes of other peer-to-peer networks like IPFS and Ethereum and everything. And then in Marine there is the macro which does the binding to how you call it, like this link wasm import module. And then we talked about it, but my question was the host, that is the Docker container of the Fluence node, or is it the server?
Well, it depends on how you run the Fluence. If you run it in a Docker container, like the default setup, that's the default setup, then it will look for binaries in Docker containers. So in that case, the host will be Docker container, but nothing really stops you from running Fluence without Docker. It's not required at all. Fluence is rather simple. You just run it and give it configuration file, and that's it.
Yeah, you could also make a Docker which contains other nodes.
Yeah, and you don't even need to contain other nodes. You just need it to contain binary that will be clients for other nodes, right? They can work through local network like they usually do.
But you could also just use the curl to go to the local host of the server, and then make the call to the like say an IPFS node that's basically outside the Fluence. So you have your internal IPFS node with Fluence, and then you have your sort of external, but which is still a local host.
Yep.
Yeah, I was also thinking about that. So then you're still using curl, but you're not doing a DNS lookup. So it would still be sort of decentralized in the sense that you're not using a DNS to find where the server is.
Yeah, that makes sense. And more to that, you're not required to use curl, right? Since Fluence node already has IPFS client binary, you can just use it. And the default Aqua IPFS library that we have in Aqua, it has the ability to work with external IPFS node.
Yeah.
It can work with that thing.
Yeah, but you still can have your own choice whether you use Aqua or you use a service.
Yep.
Yeah, that depends on whatever you want to do. I don't know.
Yeah, there's so much freedom with Fluence that sometimes it's too much.
Yeah. Anyway, well, that was my question, I think. Yeah, that was my question.
Okay, any other questions, suggestions, comments?
Laments.
Yeah, just hello, Ryan. Hi, if you have any question, you can drop it also. Yeah, very welcome, first time joining. Yeah, just wanted to remind and to let you know, if anyone wants to start project with Fluence, building with Fluence, or have any ideas, feel free to reach out to us in any channel, reach out to me in DM. We really we are very helpful, and we would be happy to help you if you have anything. So yeah, don't afraid to ask for support. Okay, so if there are no questions so far, maybe Alexei, you can take it forward. And,
yeah, sure. Thank you. Well, I can give a little little update about the bugs we were fixing in the core. We had some connectivity bugs, were recently, or at the not so recently, at the beginning of this year, we updated libp2p. It was done in a kind of hurry. We finally switched from our fork of libp2p to vanilla to upstream libp2p, and it brought some API changes, which we're still debugging and finding bugs and stuff like that. So there was a funny little bug and another one and then another one. So connectivity should be better right now than it was like a month ago. So if you have any connectivity troubles, let us know. Okay, so my idea for today demo, don't be scared for this much code. I will write it like in a separate file from beginning. My idea for today demo is to go through this Aqua script and write it and explain what I'm doing. The idea of this script, as comes from its name, is to check whether a node is up or not. So the idea is that we have some node, some peer in the Fluence network, and we want to check whether it's reachable from other peers on the Fluence network. Like, for example, it can come handy if you have your own Fluence network, or you're having several JavaScript peers, or you're having you're maintaining your own Fluence nodes, something like that. In that case, you sometimes want to check whether the node you're running is accessible from your nodes or from other network nodes, or maybe you want to check whether your peer is accessible from others, because sometimes if you're behind the node, it's not accessible, so you might want to check for stuff like that. So that's the goal of this script, and let's start writing it like in a separate file, just so it's not too much code, and you can bear with me through the whole process. So first thing first, I don't even need that so far. First thing first, I want to create a function that accepts like target node, the node I want to check, a list of validator nodes. Those are the nodes that will check if my node is available, and timeout. It sets threshold when after which we think of node as unreachable. So okay, maybe I should split layout like this. No, I didn't want that. I meant single, and I meant split, like left, right. Okay. So I can take a look at the script. Okay, so the idea is to let's start simple and let's first check whether we can return something from the function, and if it works, and how to run the function at all. Like here we return a list of strings. So let's check if it works. First, we would need an import of built-ins, of Aqua built-ins. It has some type definitions like peer ID and stuff like that, and some functions that we will find useful as we write code. But it's basically a default import. So if you want to do anything, you usually want to have this import in your file. Okay, so let's try whether it works at all. So just test. Just create a sample list and return it and see if it works. I'll save it as like demo Aqua. Okay, and now I will switch to the terminal. Let me make it a little bit bigger so you can hopefully see the text. So I have this demo Aqua here in this directory. So let's run it. I pass this file to Aquarun. Aquarun is a tool. Aqua is a tool that allows us to compile Aqua code and also run it right away. So Aquarun is what you want to use when you just develop in Aqua and you want to check some things and you want to play around, debug something, or just try Fluence. That's an awesome thing. So first argument is the file that we want to work with. It could be a directory also, but I use the file. And the second thing is the function that I want to run. Check node is up. I believe that was check node is up, correct. But this won't work. Yeah, because we didn't pass what node we want to use as a relay. Since Fluence is a network, it's an open network, anyone can join it. But in order to access it, you need to have some entry point, right? It's like a big bunch of peers, but you want to know at least a single peer so you can reach it and say, hey, please run this Aqua script. So in our case, we can take like our first node, but it still doesn't work because why? Because I didn't pass arguments to the function, and it says that it expected 3 arguments, but we passed 0. It actually, you see, it's a bug. It reports incorrectly number of arguments. It messed up. Okay, so first we need to pass target node, then validator nodes, then timeout. How do we do that? Let's do that like this. Validator, timeout, but this won't work right away because those variables will be just undefined. For them to have some value, we need to pass it as JSON. Like target is, for now, I will just put placeholders, but then I will fill it with real values. So here we need to have a list, just a JSON list. And timeout something like 5 seconds. It's in milliseconds, so 5,000 milliseconds. Unexpected something. I forgot to put quotes here. Okay, and we got our test data back. So it works. Aquarun works. That's nice. That's always nice when something works. So let's remember what we are here to do. The goal is to check that target node is reachable from each validator. Yeah, that's our goal. For that to reach the goal, we first need to decide what's our target node and what are our validator nodes. In Fluence, in Aqua tool, we have this thing, config default peers, that gives us a list of peers that we can use. It's like a peers maintained by Fluence. It's just hard-coded list here in the tool, just a nice thing to always have peer addresses to copy paste, but actually there are more peers in the network and we can't hard code them into our tool because they join, they leave and stuff like that. But this one are stable and others are stable too, but this one, so we know we maintain them, so we hard coded them here, so it's easier to copy paste it as we go. So let's copy paste it all. What we need from those peers, so you see this is kind of a network address that starts with a protocol name, then domain name, then protocol for networking, then number of the port, and finally protocol that we will use on top of the TCP. And after that, peer ID. It's kind of basically public key of the peer that we want to use. So it's kind of like HTTP //google.com, but instead of like using this syntax in browsers, we're using multi-address syntax. It's much more flexible and allows us to specify different different protocols to use. Okay, so we don't need the networking part here because Fluence is a network in itself and it can discover nodes only by their peer IDs. So let's say that this will be our target node, and those will be our validators. Okay, nice. So in that case, what we want to do first, we want to check whether validators themselves are available from our relay. Yeah, there's also a notion of relay, like entry point. Basically, it's an entry point to the network that I was describing before. We can choose some other node for that purpose, like this one. In that case, we do need our networking part, because when we're connecting to the network, to the entry point, we need to know where to connect. Once we're connected to the network, we can operate just purely on peer IDs, and network will discover them automatically. But when we're just connecting, we need to know to what server and what port and how to connect to the network. Okay, so we have our validators, and we want to check if they're reachable at all. What we will do? Let's first iterate through the array, through the list of validators. Right, and here we need to go to validator. We have this on thing, on keyword in Aqua. It tells to do something on validator. So here we can, for example, do something. But what we want to do? First of all, we want to return some data, right? Before it was test like ABC, but now we need to start returning some real data. So let's define a string of results. Yeah, and let's write something there. For example, we can do something like that. Will it work? And we can return results from here. So what we're doing here, we're going through all validators. We're making a topology hop, like a network hop to the validator. On the validator, we execute service op function identity. What it does, it just returns us hello back. And we write it to result. Yeah, okay, let's try to do that. I think it won't work right away. Yeah, it didn't. It says that op identity expects us to pass optionals, or like an optional string there. And we do convert string to optional string here. So let's try that. Will it work? Will it time out? What will happen? I don't know. Yeah, it did time out. I wonder why. Shouldn't. Let me increase the timeout from 7 seconds to like 20 seconds. I wonder why timeout shouldn't time out.
You have a result that is singular and you have results that is plural.
Oh, yeah, you're right. So this is a kind of, yeah, right. And so I don't return anything, but it still should have work, should work and return. Yeah, now it complains. Yeah, that makes sense. Okay, what should we do about that? We should just put it like this, like hello, and do it like this. So what happened here? Op identity is a function that looks like this. So we have a service op, and we have a function identity there, and it returns the same thing that we passed there. So you see, we passed optional string there, and it returns optional string. but result expects just a stream of strings. So we can't easily write the optional string back to results. So what I do is I make just string from optional string by using this operator exclamation mark. It doesn't mean anything. Yeah, so in this case, it converts from optional string to just string. So let's try if it works. I hope it, yeah. And we need, and we need to do like that, I believe. No? Yeah, and it complains that this service is already defined. Seems like it will time out anyway. Ah, right. Why timeouts? I wonder, because I didn't pass the correct validators here, right? I just trying to reach node AAA instead of correct validators. So let's put correct validators, 2 arguments. It will look like this, right? Just a JSON string. And let's put correct target right away, so we so I don't make the same mistake again. Okay, so target. Okay, and let me copy paste the command to make it more readable. Okay, and we have 2 hellos. Nice, but no way to tell which validator returned what, right? We might want to have more information. So first, let me paste the command and make it like several lines, like so it's more readable. Let's do like this. I just created a new file. Sorry for being for jumping everywhere. Just want to make it easier to read. So let's make it a multi-line command. By the way, if you have any questions, you can just go and ask me. I will be happy to answer you. Okay, that. Okay, I think this is far more readable than before. We're calling check node is up from file demo.aqua, and we're passing this JSON to aqua run, so it can like use those variables right away in the function call. Right. Why? Okay. Great. So let's run the command again to check if I did it correctly. Okay, we have our hellos. Nice. So let's make it more meaningful. We can return instead of doing this thing and returning hello, we can do a special operation that does nothing. It's called op no op. It just does nothing, but it still forces Aqua to go to the node, to the validator. So, okay. I think my cat drank from that cup. Not sure. Okay, what we want to write here? I want to write a validator address. So this way we would be sure that we went through each validator, right? So this is a script that goes through each validator, writes its address to the stream and returns the stream. Let's try how it works. Okay, nice. Let me clear the terminal and run it again so it's more easy to read. So I run this command and I get this result. So we went through each of the validators, this one, and we returned their addresses back. So that's already great. That's already a distributed algorithm, maybe a very simple one. But still, it describes a network hops between several nodes and getting a result back. Okay, so we're sure that validator is those validators are reachable from our relay, so we can like report it. Let's rename results to statuses, and right here that statuses validator is reachable, right? And return statuses here. What will happen? We will have, as a result, we will have array of 2 strings of 2 messages, validator is reachable. Not much sense in that because we won't know which validators are reachable, right? We want to add an address of the validator to the status. How do we do that? In built-in Aqua, there is a service op, right, that has an identity, but also it has a function that's called concat strings that accepts actually any number of strings under the hood. But in Aqua, we don't have means to express that. So in order to use concat strings, you usually have to redefine service, right? So, and say how many arguments you want to concatenate. You just have to do that. So I want to concatenate 2 strings here, or no, I want to concatenate 3 strings. So A, B, C string. And I want to do it like this. Op string, concat strings, validator, like I need space here, is reachable. So it's kind of not very good visible, like this. So I concatenate those 3 strings, 1, 2, 3, and get a status from the function. Let's take a look how it works. Didn't work. Expected string given something else. Oh, I forgot to return a string here, right? Okay, so that's much better. We have validator ID and it's human readable, and we see that it's robot reachable. Okay. But what will happen if we pass a node that's not reachable? Let's try. Like I know that XXX isn't a real peer ID, so it's not reachable for sure. So let's try to do that. What will happen? Actually, we already know what will happen. It will just time out. After 20 seconds, it's where really a lot of time. So let's put it like 1 second. For now, I think it will be better. But do timeout. Yeah, so it did timed out. After 1 second will be faster. Great. So we don't have any way right now. We don't have any way to tell that like to return status unreachable, but we need to have one, right? For this, we have a pattern called race. It's described actually. It's described on FluenceDev in Aqua book. If you take a look at the language execution flow, parallel, race pattern, right? So the second example is what we need. It's exactly about that. So we go on some peer, we try to execute something there, and then we return status back. And if it doesn't happen, then we time out and report status timeout. Let me do that and explain to you how it actually works. And I feel like it will be everything that I can cover in my time span. But I think it's already a lot. So what do we have? We have a function peer.timeout. It's here in the built-in Aqua file. we have this function. What it does, it sleeps for this amount of milliseconds and then returns the string that you have passed there. So how it works and what happens. So we have basically two things that race each other. We have this block of code that goes to validator, does operation that does nothing, and returns status back. And if validator isn't reachable, this will take a lot of time, like forever, unless we put a timeout on that. And the second branch of this like racing pattern is this. It will run for exactly 1 second and then return string timeout. So if we do it like this, we write to statuses either this status or a string timeout. It will be who is faster, like who's faster, that will write the status first. Let's do that and see what happens. Not enough time. Let's give it 2 seconds. Yeah, you see what happened? We have like I added 3 validators, and first one timed out, so we see that it timed out, but we don't see like its peer ID or it's not a very good user experience. Let's improve it a little. Let's do very same thing, but here I wonder if time it out, right? I wonder if it will work. I'm not sure if Aqua allows to do that. I hope so. Yay, almost there. Forgot to add space, but still, we see that validator XXX timed out because there is no such validator, no such node in the network, so it's unreachable. Okay. Anna, what about time? Are we okay?
Can I interrupt with a question?
Yeah, sure, go.
Why on line 11, is it like a double arrow back and on 12, a single one?
So before it was like this, right? And when you write usual value, just a value, just a constant value to the stream, you have to use this operator. But when you're using function, you have to use this operator.
Yeah.
Yeah. So this or this doesn't really matter. I believe it's a kind of bug in a parser. So before it was 2 different operations, and now it's not. Maybe Dmitry wants to add something to that. It's kind of a mystery to me too.
Yeah, because I was thinking if it's a surface, I have to do it like this. And if it's just a string, I can use the double ones, but it works with the surface, it works with the double ones as well.
Yeah, it seems so.
Okay. Yeah, and I just learned the thing with that I have to rename this op surface.
Mm-hmm.
That's also because that confused me also. It's like sometimes it was working, I could do something with this, and now I know that I have to rename it. Yeah,
it's a very powerful technique that comes from
to everything, but yeah, now I know that because sometimes it worked with me and then sometimes it didn't work anymore, but now I know why, so that's good.
Yeah. So for example, if you have something that you want to return through op identity or something like that, you can do like op number, or you can call it like any way you want, right? Whatever you call it, but just make sure to put the correct service ID here, and then you can define identity that takes like number and return, I mean, U32 and returns U32. It will work because under the hood, it's what's the word for it? It's a general function, like polymorphic function that accepts any type of argument and returns it back, but Aqua doesn't yet know how to do that, how to express that. So we have to have this approach of overloading services. Okay, that's a word.
I've tried to make like a products with stuff like this, because if you just it just fills them with the order you put the arguments in, sort of, sometimes. Anyway, just go on with your example.
Yeah. So are we okay with time, or I'm not sure. I didn't follow the clock. So
we still have 15 minutes.
Okay, I think 15 minutes is enough. So okay, we have this thing. It checks whether our validator is reachable or not, but actually it doesn't really work well. So first error is that I hard-coded timeout here. It doesn't really work very well because it always writes to statuses. So for example, if we take a very short timeout, let's try to do that, like very short, like 1 millisecond, we will see maybe, no, of course. And if we remove this thing, and if we run it, you see that all validators timed out. I guess sometimes we will see different messages. No, it's too fast. What I want to show you is that in this case, it's kind of, what's the word for it? You can say what will happen. You can say what will happen because both this operation writes to the stream and this operation writes there too. So it may happen that this operation wrote and then this operation also added the value. So even if you pass 2 validator nodes, you can have up to 4 statuses because both of the separation write to the same stream, and it's non-deterministic which order it will happen, in which order it will happen. So how to cure that? We introduce status, like validator status. Variable, it can be actually like this, but there's no difference, not much difference. We put it like this. And we don't, right now, you see, we don't write anything to statuses. So statuses will always be empty. Only validator status, we should do it like this. Only validator status will be filled with either this value or this, like this value, or this one, or both of them. You can say how it will be. But what you can say is that which one is first, it wins. Like you can say that which one is fastest will be the first one. So let's wait for at least one answer here, right? So we can have either this branch complete, like this branch, or this branch complete first, or both of them can complete in almost the same time, and we'll have both values there. So, and what we do, we write validator status, the first validator status to the statuses string. So this way, right? Yeah, correct. This way, what we do is we always make sure that only the faintest status will be written to the only the single status will be written to statuses stream for every validator. So we always will have invariant that there's as much statuses as there are validator nodes. Okay, so let's run it and see if it works. Timeout. Yeah, it's a very, very small timeout, so it will never reach it. Let's put 2 seconds at least. Yeah, both of them reachable, and let's put XXX back so we check that it's unreachable always. Time it out. Too little time. We gave it too little time. So you see, I gave it timeout 2 seconds per validator, but per the whole script, I gave only 1 second. That's not very smart of me, because it will always time out. Okay. Okay, great. So this works. And you see, somehow this node managed to time out, even though it has whole 2 seconds to respond. Maybe it's under the load right now. Maybe that's the reason. We can increase it to like 4 seconds, but still. Okay, nice, nice. We have validators checked for reachability, and now we can go and check our actual target node for reachability. So what should we do? What should we do? First, we should put validator status. We should check our target node only in case validator is reachable, right? Right. So first we want to put validator status to some variable like this. This is needed to overcome bug in current Aqua. Basically, it's it's more a usability kind of usability issue that you can't write if on streams. It will cause bugs, but you will see right now. So we saved validator status to variable, and now we need to compare. Status, but we actually cannot, or can we? Yeah, we can compare it. So if Veste equals this, right? Like we can even move it to some variable, but whatever. So if it equals this, then we can put status, write status to status as string. Okay, sorry, I a little bit got carried away by the code on the left. Okay, so we check if validator is reachable, then we can proceed and check target node. Let's do that. We do the same, and we have to do like the same thing. We need to define a variable that we'll call target status string, optional string, and we write here target is reachable from, we have 3. Well, okay, target, whatever. Target is reachable from validator. Yeah, target is reachable from validator. Okay. And we also have to do the same pattern as before. Target status. Oh, you see, I put those arrows again. Peer timeout. Timeout. Op string concat strings. Target is not reachable from validator. A little bit long. I can do it like this, but I think it's less reachable. But you know that this is not reachable, this is reachable, so I guess it's fine. Okay, we did the same thing. And now we need to, so if validator was reachable, when validator was reachable, we checked the target and saved its status. In case validator wasn't reachable, we can just report validator status back to statuses. In case validator was reachable and we checked the target node, we can write target status to statuses string. We first want to join it for at least one target. Okay. So I hope this will work. Let me do it like this so it's easier to read. Oh, at least. Let's try to run it. Expected end of string. What did I do wrong? Ah, you cannot do that. Okay. Okay. You have to do this like this. Strange. No. Ah. Where did I? Ah, it was here. Okay. Just a typo. Wow. Sorry for being too fast. So, and we have three statuses. First one says that validator XXX, which is an invalid node, timed out, and second and third statuses say that target is reachable from the validator that we use. So that's nice. That's nice. What happens here? Let me try back this. And I will go line by line, again, explaining what happens in the code. I have 4 minutes for that. Nice, it works. So we run this command, same script, same function, same arguments, and we get this status. So what we did here, we checked that this node is reachable from every validator in this list, and we gave this much time as a threshold to determine whether to consider node reachable or not. First, we checked validators, right? Check that validators are reachable. Then, in case if validator was reachable, check that node is reachable from that validator. Yeah. So yeah, we first checked that validators themselves are reachable. Then if validator is reachable, we checked that target node is accessible through this validator. And we reported that to the status, and we returned array of statuses. One more thing that we can improve here, we can put par here. So this all happens faster. So I just added par here, and every iteration, hold this code, for every validator will be run in parallel. So if we have 2 validators then it will be 2 parallel processes. If we have more, it will be more parallel checks. But if we do so, we must be careful, because if I just run it, you see, I will get an empty result. Let me do it again. I just get empty result. Why? Because we added par here. So all this thing completes immediately, just like that, and returns immediately. And it didn't got any time to write statuses back. So we need to wait for statuses to be reported. But how much statuses do we want? Do we want like 10 of them? We have only 2 validators. So we probably want to have 2 statuses. But since we're using array indexes here, they start from 0. So we need to use 2 minus 1. That's 1, index 1. We have 2 validators, and we need to use index 1. That's not very good because I hard-coded the index just to make statuses. Yeah, you see, we have 3 validators, so I need actually to put here number 2. Like we are waiting. This expression says wait for array statuses to have element with index 2. So that's like, since it's 0 indexed, it's like this. So this way we're waiting for 3 elements actually. Let's run it again. And we'll see, yeah. And you see this validator keeps timing out for some reason. That's good, we have some variety. But you see that we have all 3 statuses. But what will happen if we put here 4 validators, right? Like if we had, we need now to change our script, or it will report only 3 statuses out of 4. Or it will wait at least for only 3 statuses. So we need to calculate this number instead of hard coding it. How do we do that? We have op array length here, and it can work with PIDs, because PIDs is just strings. So we do this, and we calculate a length of the validators, how many validators we have, and we subtract 1, so to account for indexes being 0 based. Let's run it again. And yay, it works. And we have this script written just now in like 30 minutes or something. Great, I think great. Do you have any questions about what happens here? Anything? I understand it was kind of involved, so. Okay. That's fine. That's fine. That was it. That's how you can write different distributed algorithms in Aqua. If you try to implement something like that in any other language or anything else that I know of, at least, it will take a lot more time. And here you can see the essence of what's happening right away. It has some quirks, but it's still a nice tool.
Thank you, Alexei. It was awesome.
Yeah, I also liked it. I was mostly happy that I understand a little bit of what was going on. Gives a good feeling.
Yeah, thank you.
Thank you, Felix. Anyone has any questions? Suggestions? Comments? Okay, if we are good, we're done. Thank you everyone for today. And we see you in 2 weeks. That's as a reminder. Yeah, thank you. Thank you, everyone. See you soon.
Thank you. Bye.
Thank you.